In this lecture, we are going to find particular integral of f of d into y is equal to q of x, where q of x is equal to x power k, which is nothing but a polynomial. So f of d into y is equal to x power k, and particular integral is given by 1 by f of d into x power k, as we have discussed in the previous videos. Now the working rule. First of all, we have to reduce our 1 by f of d to the form of 1 plus or minus phi of d by taking lowest term of f of d. First of all, we have to find the lowest term of f of d. Then we have to take that term outside from f of d. Then we'll take the form of 1 plus or minus phi of d. So, to bring this 1 plus or minus phi of d, it will become 1 plus or minus phi of d whole inverse into x power k. This is nothing but our one equation. We expand this 1 plus or minus phi of d whole inverse by using binomial expansions, which are discussing next, up to d power k, where k is the power of x. We have to observe the power of x here, and up to the in the expansion of binomial expansion, we have to take only the terms up to d power k. All the higher order terms are to be neglected. Then multiply your x power k into the terms which you have obtained in the expansion. Then we get the answer. So here, one note, if f of d is resolvable, then split f of d into partial fractions. Then we can operate the same procedure. So the binomial expansion formulas which are very useful for this topic are 1 minus 1 by 1 minus d can be written as 1 minus d whole inverse, which is equal to 1 plus d square plus d cube plus and so on. Here we have to observe carefully. If it is minus inside and the power is minus, then all the terms will take plus. Means 1 plus d square plus d cube plus and so on. 1 by 1 plus d is equal to 1 plus d whole inverse, which will be taking the form 1 minus d plus d square minus d cube. Means alternative plus minus should be obtained if plus is inside and minus is in the power. Similarly, 1 by 1 minus d whole square is nothing but 1 minus d whole power minus 2, which will be 1 plus 2d plus 3d square plus 4d cube. Since minus is inside in the power, all the terms take plus in the expansion. So 1 plus 2d plus 3d square plus 4d cube. Similarly, 1 by 1 plus d whole square is equal to 1 plus d whole power minus 2, which is nothing but 1 minus 2d plus 3d square minus 4d cube. First problem, solve d cube minus 3d minus 2 into y is equal to x square. So the given differential equation is d cube minus 3d minus 2 into y is equal to x square. This is in the form of f of d into y is equal to q of x. So the solution is y is equal to complementary function plus particular integral. To find the complementary function, the auxiliary equation is f of m is equal to 0 implies m cube minus 3m minus 2 is equal to 0. So using synthetic division, m is equal to 2 is one root. After synthetic division, it becomes m minus 2 into m square plus 2m plus 1 is equal to 0. So which is nothing but m minus 2 into m plus 1 whole square is equal to 0. Therefore, the roots are m is equal to 2 comma minus 1 comma minus 1. As we have discussed in the previous videos, the complementary function now it will be c1 e power 2x plus c2 plus c3x into e power minus x. Now, to find the particular integral is equal to 1 by f of t into x power k, which is equal to 1 by d cube minus 3d minus 2 into x square. If you observe the f of d, the least term is minus 2. Okay. So you have to bring that minus 2 outside from f of d. Then it will be 1 by minus 2 into it. Since minus 2 came outside, it will be 1 minus d cube minus 3d by 2 into x square. Now you bring this 1 minus d cube minus 3d whole by 2 to numerator. It will become minus 1 x square. So already we discussed the binomial expansions. By using the binomial expansion formula for 1 minus d whole power minus 1. So this the whole part you have to consider as d. This whole part should be considered as d. This will be in the form of 1 minus d whole power minus 1. So the expansion is 1 plus d square plus and so on. So 1 plus d cube minus 3d by 2 plus d cube minus 3d by 2 whole square plus and so on into x square. So after writing this, we have to collect only the terms up to the power of our x. So the power of our x is 2 here. So you have to take up to only d square. After higher order derivatives from d square should be removed. So neglecting higher order derivatives from d cube after d cube, from d cube we should not take any derivative. So it is equal to minus 1 by 2, 1. So here d cube by 2 will not come because it is higher order derivative. So minus 3d by 2 plus, if we expand this whole square, it will be a square plus b square minus 2ab. A square will be equal to d power 5, which is not eligible to take. Next, b square minus 3d by 2 whole square. It will be 9d square by 4, which we can take. Then minus 2ab also it becomes d power 4, which should not be taken. So you have to observe carefully here what are the terms we have to include in our term here. After higher order derivatives should be removed properly. So minus 1 by 2 into 1 minus 3d by 2 plus 9d square by 4 into x square. While taking these terms only, you have to be very careful. After this, the problem can be solved easily. So your concentration should be here. After expanding, what all the terms we can take. So here x square is there. So up to d square only we are eligible to take, because why we are taking? Because d cube x square. So dx square is nothing but 2x. What happens to d square x square? It will be 2. If we take d cube x square, it will be becoming 0. So higher order derivatives will be 0 after d square. So 1 minus 3d by 2 plus 9d square by 4. Now you multiply your x square into these terms. So minus 1 by 2 into x square minus 3 by 2 into dx square plus 9 by 4 into d square x square. Now dx square is nothing but differentiating x square one time we get 2x. Differentiating 2 times we get 2. So after solving, we get particular integral is equal to minus 1 by 2 into x square minus 3x plus 2. So substituting this complementary function particular integral in the solution, y can be obtained as y is equal to c1 e power 2x plus c2 plus c3x into e power minus x minus 1 by 2 into x square minus 3x plus 9 by 2. Next problem. Solve d cube plus 2d square minus d minus 2 into y is equal to 1 minus 4x cube. Now the given differential equation is d cube plus 2d square minus d minus 2 into y is equal to 1 minus 4x cube. Now clearly this is in the form of f of d into y is equal to q of x. The solution is complementary function plus particular integral. So to find complementary function, the auxiliary equation is given as f of m is equal to 0, m cube plus 2m square minus m minus 2 is equal to 0. Using synthetic division, this can be written as m minus 1 into m square plus 3m plus 2 is equal to 0, which can be written as m minus 1 into m plus 2 into m minus 1 is equal to 0. Therefore, m is equal to 1 comma minus 2 comma minus 1. Clearly, the roots are real and distinct. So, therefore, the complementary function is c1 e power x plus c2 e power minus 2x plus c3 e power minus x. Now, to find particular integral is equal to 1 by f of d into x power k, which is equal to 1 by d cube plus 2d square minus d minus 2 into 1 minus 4x cube. Since in this term, the least term is minus 2, so bring this minus 2 outside. If you bring this minus 2 outside, it will be 1 by minus 2 into 1 minus d cube plus 2d square minus d by 2 into 1 minus 4x cube. If we get this term to the numerator, it will be minus 1 by 2 into 1 minus d cube plus 2d square minus d by 2 whole inverse into 1 minus 4x cube. Now using binomial expansion, first of all, before you applying the binomial expansion, just be careful on the power of your x. Means up to x cube. Means we have to get terms up to d cube. So since inside minus and power minus, all the terms will take place. So 1 plus, as we have discussed earlier, we should consider this whole part as some d. So it is nothing but in the form of 1 minus d whole power minus 1. So 1 plus d, which is nothing but d cube plus 2d square minus d by 2 plus d square, which is nothing but d cube plus 2d square minus d by 2 whole square plus d cube, which is nothing but d cube plus 2d square minus 2d by 2 whole cube plus and so on. So the highest power, the power of x is 3. So the derivative should be containing only up to d3. Higher order derivatives from d4 are to be neglected. So neglecting higher order derivatives from d4. First of all, observe the terms carefully. 1 will come. So in this term, d cube by 2 plus 2 gets cancelled, d square minus d by 2. Now in this whole square expansion, if we whole square this, it will be d power 5. So you should not take this. Next, d square whole square becomes d power 4. This also does not come. Now d square, this should be included, which is nothing but d square by 2 whole square, which is nothing but 4. So any other terms, 2ab, a plus b plus the whole cube, according to a plus b plus the whole square formula, you can also take this term by multiplying these two terms. 2bc, which is nothing but minus 2 into 2, 4. D square into t becomes d cube by 4. Minus, here it is in the form of cube. So this term cannot come because it will take whole power 9, and it will not come because it will take whole power 6. But if you observe this term carefully, this term will be included. Means minus d by 2 whole cube becomes minus d by 8. Sorry, minus d cube by 8. So these are the terms which are in our expansion after excluding all the terms from d power 4. So this is equal to minus 1 by 2 into 1 plus d cube by 2 plus d square minus d by 2 plus d square by 4 minus 4d cube by 4 minus d cube by 8 into 1 minus 4x cube. So after simplifying these terms, we get minus 1 by 2 into 1 minus 5 by 8 into d cube plus 5 by 4 into d square minus d by 2 into 1 minus 4x cube. Now multiply this 1 minus 4x cube inside. You will get 1 minus 4x cube minus 5 by 8 into d cube into 1 minus 4x cube plus 5 by 4 into d square 1 minus 4x cube minus 1 by 2 into d into 1 minus 4x cube. So d 1 minus 4x cube is derivative 1 minus 4x cube one time, you will get minus 12x square. D square 1 minus 4x cube means derivating this, you will get minus 24x. D cube 1 minus 4x cube means again derivating, we get minus 24. So substituting all these values here and simplifying, we got the particular integral as minus 1 by 2 into minus 4x cube plus 6x square minus 36 plus 16. So substituting 1 and 2 in A, you get the solution y is equal to c1 e power x plus c2 e power minus 2x plus c3 e power minus x minus 1 by 2 into minus 4x cube plus 6x square minus 30x plus 16. From this example, what we have noted is, if it is a polynomial, if the given function is a polynomial, no need to find for the constant separately. In the previous examples, what we have done, while doing q of x is equal to e power x, we have considered the constants as constant into e power 0x. But in the polynomial section, it is not necessary to consider the constant terms as a separate term. We can include it in a polynomial and we can do the same operations in the same procedure. Next problem. Solve d square plus 5d plus 6 into y is equal to 1 plus 2x plus x square. The given differential equation is 1 plus d square plus 5d plus 6 into y is equal to 1 plus 2x plus x square. So this is in the form of f of d into y is equal to q of x. The solution is y is equal to complementary function plus particular integral. To find complementary function, the auxiliary equation is f of m is equal to 0. M square plus 5m plus 6 is equal to 0. M plus 3 into m plus 2 is equal to 0. Therefore, m is equal to minus 3 comma minus 2. Therefore, the roots are real and distinct. Hence, the complementary function is c1 e power minus 3x plus c2 e power minus 2x. Then particular integral is equal to 1 by f of d into x power k. Since it is a polynomial, you have to consider it as a single term. So 1 by d square plus 5d plus 6 into 1 plus 2x plus x square. So this is equal to 1 by 6 into, since 6 is the least term, constant is the least term here, bring your 6 outside. So it is 1 by 1 plus d square plus 5d by 6 into 1 plus 2x plus x square. So if we get this into numerator, it will be 1 plus d square plus 5d by 6 whole inverse into 1 plus 2x plus x square. So using the binomial expansion, since it is plus inside and minus outside, so alternative plus minus will be obtained. So it is 1 minus d square plus 5d by 6 plus d square plus 5d by 6 whole square minus d square minus 5d by d square plus 5d by 6 whole cube plus and so on into 1 plus 2x plus x square. So after expanding, neglecting higher order derivatives from d cube, since the highest power of x, in this case, in the case of polynomials, we have to observe the highest power of x. So the highest power of x is x square. So up to d square only expansion term should be there. Neglecting all the derivatives from d cube, we can get 1 minus, in the first term, it is d square by 6 minus 5d by 6. So in the second term, a plus b whole square. A square cannot be obtained because it is d power 4. B square can be obtained, which is nothing but 25d square by 36. 2ab cannot be obtained because it will be d cube. And here d cube terms also cannot be obtained. So into 1 plus 2x plus x square. So this is the main important step of our particular integral because you have to correctly choose the terms. So after simplification, it is 1 minus 5d by 6 plus 19 by 36 into d square. Now multiply your 1 plus 2x plus x square inside. So it is 1 by 6 into 1 plus 2x plus x square minus 5 by 6 into d of 1 plus 2x plus x square plus 19 by 36 into d square into 1 plus 2x plus x square. Now d of 1 plus 2x plus x square is nothing but 2 plus 2x. And d square of 1 plus 2x plus x square is nothing but 2. So substituting the values here and simplifying, you get the particular integral as 1 by 6 into x square minus x by 3 plus 7 by 18. So substituting these two values in the given solution, y is equal to c1 e power minus 3x plus c2 e power minus 2x plus 1 by 6 into x square minus x by 3 plus 7 by 18.